వేయాలా? అది నాగపూర్. అది మాకు దగ్గరనే భాష అట్లనే ఉందని ఇక్కడ టీచరా లేకపోతే ఇందులోనే టీచర్ మేడము నేను అమ్మ గవర్నమెంట్ కాంటాక్ట్ కానీ ఇక్కడ రాలేదన్న. అదే ఈ నెల ఇంటికి పోతానైనా ఇంక సొంతంగానే ఏడుంటా రామ్నగర్ లో ఉంటాను. రామ్నగర్ అని ఆర్టిస్ట్ క్లాస్ ఉంటుంది. మేము అక్కడ ఉంటాం. సూరారం నుంచి వస్తారా మీరు? చాలా దూరం లేదండి. ఇంకా అలవాటు అయ్యింది. ఇంకా మానుకుందాం అంటే వస్తారు. పాస్ ఎమ్మడే గుర్తుపట్టేసిన. Good morning, everybody. So today our class WKB approximation method. WKB approximation method. Hello, everybody, please. So WKB approximation method. Today our classes. What is the WKB? WKB is the meaning of Wendell. W mean Wendell. K mean Tramers. B mean Brilliant. Okay, that is WKB approximation method. This is three type of method. Approximation method, variation method, WKB method, and next variation method, WKB method, approximation method. That is a three type. So you have to class WKB approximation method. This is a 10 marks question. Is a very important question. This is a 10 marks question, compulsory question that one. Okay. So this is method consists of either expanding the wave function, the in the power of h card, if each series is the semi convergent in the character, it can be used for approximation method solution of the Schrodinger equation. So Schrodinger equation is the depending on the two type of Schrodinger equations, time independent and time dependent Schrodinger equation. So this theorem, this method, WKB method, is depending on the time independent Schrodinger equation. Time independent Schrodinger equation in the one dimension. So your WKB method is of Schrodinger. Write the Schrodinger equation. Here. D square j by dx square plus 2m by h square into e minus b to j is equal to 0. This is the Schrodinger equation and d square j by dx square plus 2m by h square into e minus b into j is equal to 0. That is the formula. So here v is your textbook. Your textbook page number is 236. 236. Anybody please reply?
Sir.
Okay. It is clear?
Sir, కొంచెం బ్లర్ వస్తుంది సార్.
Okay.
షేక్ అయినట్టు అనిపిస్తుంది.
That is a fan problem.
Okay, sir.
1 minute. Okay.
Okay, sir.
So here this is the time independent Schrodinger equation as a depending on Page number 236. Listen. Page number 236. You are observed that your textbook. Okay. So V is the constant of the solution. V is the constant of the solution. This is the solution of the form. This is the xi. Xi is equal to E plus or minus I k x Okay. So here this is the formula k is equal to you write the value this value right this is a k. So this is a k value. The formula you are observe the formula k is equal to 2m by h star square 2m by h star square into e minus v to power of 1 by 2. You write that k is equal to value. So here this is the suggestion of the v is not the constant but varies slowly with the x value. So we might the try solution of the form xi is equal to e power of I x sorry s I s of x So where here s of x where s of x this value s of x will be proportional to x proportional to x. Yeah, these are two cases there. The proportional to x value is simplify the two cases. This one v of x value and this is the two values e greater than v of x, e less than to v of x. That is the value to two cases that divide in this value for this formula only. So that value write this. First one is here e greater than v of x, then k of x is equal to 2m by h star square e minus v of x of is equal to into xi is equal to 0. Okay. So xi is equal to 0. Don't write this xi value, only you write the power of 1 by 2 v of x. That is the real quantity. That is real quantity. Next second one is e less than v of x, then k of x is equal to 2m by h star square e minus v of also greater than is also v of x minus v value is equal to 1 by 2 is equal to ik is real quantity. That's the equation. So for e greater than v of x, write this. E greater than v of x is a we get the formula equation. You are observe the equation 22.46. Equation 22.46. That equation you are observed 22.46. This equation you are observed. That is equal to d square xi by dx square plus k square xi is equal to 0. D square xi by dx square plus k square xi is equal to 0. So you are observed that formula. This is k square value. You are observed. This is the k square value. Okay. The k square value. You are observed this value. You are substitute here. This value. The k value is here. The k value substitute here this formula. Okay. So that is the substitute in the 22.48. 22.48 in 22.46. 22.46. We get the value. We get the value. The equation of the x dependent phase. X dependent phase. Dependent phase. Phase. S of x. S of x. So S of x, sorry. So next to d xi by dx is equal to d xi by dx is equal to I s e power of I s e power of I s of x. S of x. So this is derivative amma. There are observe the derivative. This is the d xi by dx is equal to I s e power of I s of x, that value. Next to d square xi by dx square is equal to I s star e power of s star of x into e power of I s of x minus I s dash of x square into d power of I s of x. So therefore we have the calculation 22.51 your equation one. You are observe the equation 22.51. You are observe your manual textbook. Okay, your textbook you are observe equation 22.51. Okay, so that value is substitute here. 22.51. This both values substitute here. This equation. This is the 22.51 equation. Okay, this value substitute here. This equation here. So next, so tell me please. Please. Please, sir, tell me anyone. Huh?
ఎప్పుడు పెట్టేసినాయి ఇలా కొట్టిస్తున్నాం ఇట్లా
Your voice is not clarity, sir. Your voice is not clarity. What?
सर क्लियर में नहीं आ रहा है
Your voice is not clarity.
Sir, please continue, sir. No problem. Please continue the class, sir.
Sir, you please continue.
So therefore we have equation 22.51. Okay. So that is observed is star x is star x e power of is of x minus s dash of x whole square e power of is of x plus k square k square k square of x e power of is of x. Of x is equal to 0. Of x is equal to 0. So your common value e power of is of x value x into e power of is of x is a common. So after we change the equation I star minus s dash square plus k square of x is equal to 0. So this is the non-linear equation. And non-linearity is used to develop as a simple approximation method. For the solving for pre-particle. This is the pre-particle. The three values s of x is equal to kx s dash of x is equal to k. Next to s double dash of x is equal to 0. That is the derivative three times. S of x is equal to kx, s dash of x is equal to k. Then s is the constant is 0. So s double dash of x is equal to 0. This value supposed here. This suggested of the procedure can be used the finding finding the solution. We assume that second derivative remains the relativity small is potential does not vary to if smallness of s double dash of x smallness of double dash of x smallness of s dash square is the value. So here minus s dash of square plus k square of x is equal to 0. This both equation you are observed that s dash is equal to plus or minus k of x is equal to k of x. Okay, k of x. So here s naught of x, you change the value. S naught of x is equal to plus or minus L of k of x dx plus c naught. That is the c naught is the value. So this is such is the approximation method can be now the derivative. If write the equation, you are of the equation 22.55 in the form of the equation the successive approximation method in the form of the equation ds of x whole square ds of x by dx whole square is equal to kx square, k square of x plus d square s of x by dx dx square dx square. That is the term of the substitute in the nth term approximation method. Nth term on the right side of the equation. The right side of the equation we obtain the n plus 1 the approximation method by the quadrature. This is n plus 1 the equation are observed. So that is the formula to support this one. n plus 1 of x is equal to plus or minus real of k square of x plus I d square s of n x by dx square equal to 1 by 2 dx plus cn plus 1. This equation number. This is the simplify the equation. This one. You have to substitute above formula. Simplify this equation is there. Okay. So next further n is equal to 0. First one is n is equal to n plus 1. There is n is equal to 0. సార్ చెప్పండి. నేను రామలక్ష్మణ్ తీసుకుంటున్నా, ఆల్రెడీ స్టార్ట్ అయింది కూడా. ఏంటనే చెప్తూనే ఉన్నా, ఆల్రెడీ 11:45 స్టార్ట్ అయింది. సో s1 of x is equal to plus or minus del of k square of x plus I d square sn. So here also this is n is equal to 0 is also here s of 0 of x by dx square 1 by 2 dx plus c naught. That is the n is equal to 0. N is equal to 0 also here what? The c is equal to c 1 number, not 1. The n is equal to 0 is also remains the 1. Okay, that is the equation. So since s naught of x is equal to plus or minus k of x. Hello? Sir. Now already 25 members would have entered in the tournament. host కూడా ఉన్నారు బీఆర్ హైదరాబాద్ host కూడా ఉన్నారు కదా సార్. అంటే వీడియో ఈయన ఆఫ్ లో ఉన్నట్టున్నారు. ఇప్పుడు చూడమనండి. So of the value here s naught of x is equal to plus or minus kx and s star s naught of star x is equal to plus or minus k dash of x. K dash of x. Okay. K dash of x. See, substituting this equation, substituting equation 24.64 22.64 in 22.65 in 22.65. That equation is our answer. Equation 22.64 in 22.65. So that is S1 of x is equal to plus or minus L of k square of x. సార్ చెప్పండి. నాకు తెలియదు సార్, నాకైతే వీడియో క్లాస్ ఆన్ అయింది, రన్ అవుతుంది క్లాస్. రికార్డ్ అంటే ఎక్కడ చేసుకోవాలా? So integral of k square of x plus or minus I k dash of x 1/2 dx plus c1 dx plus c1. This is of the equation 22.64 and 22.65. Okay. So the sign in the square root, the before square root should be same as used for the s naught. Same as for the used for s naught. Here dividing k square x. Dividing k square of x. Okay. So this equation. So you are dividing this equation. S1 of x is equal to plus or minus integral of k of x 1 plus 1 k dash of x by k square of x 1/2 dx plus c1 So next the value here first k of x value is a common. S1 of x is here is equal to plus or minus k of x plus or minus k of x into 1 plus k dash of x by hello sir చెప్పండి. So 1 plus k dash of x by k square of x, k square of x, k square of x into dx plus c1. dx plus c1. Next to s1 by of x is equal to plus or minus k of x 2 plus del of the common integral. So it is also your integral. You are right the integral amount. This is also integral. That's the mistake. So here also you have integral value plus or minus kx value is a comma the bracket here. Plus I k dash of x by k square of x dx plus c1. dx plus c1. Okay. So here j of x is equal to j of x is equal to j of x is equal to e power of I real of plus or minus k of x plus or minus k of x plus I k of x by 2k of x 2k of x to dx. So this is the j of is equal to j of x is equal to e power of I real of plus or minus k of x dx minus dx e power of minus integral of 1 by 2 integral of 1 by 2 is the 1 by 2 k dash of x by k of x dx k of x dx. So this is the k of x by k of x value linked to k of x. Linked k of x, you write that equation. J of x is equal to e power of I real of plus or minus k of x dx into e minus 1 by 2 link I L N K of x x int of x and dx of x into dx. Therefore, 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 y is equal to y is equal to y of is equal to, that is not clear that. So here you are writing this. So y is equal to y of x is equal to a by a by a by under root of the root of a of x into d power of I real of k of x dx k of x dx k of x dx k of x dx plus b by under root of k of x into d power of minus I real of minus I real of k of x dx k of x dx. So this is the similarly solution of v less than v of x, v less than v of x. So that is the y of x is equal to similarly c by under root of k of x k of x e power of integral e power of k of x dx plus d by under root of k of x into e power of minus integral of k of x dx k of x dx. So dx, this solution, this both equations are solution are valid everyone. They expected the value e minus v of x is equal to 0 comma v of x minus e is equal to 0 when in the k is equal to 0, the k is equal to 0 this is the validity of WKB approximation method is correct solution of the equation 22.59, namely we are observed the 22.59 equation modulus of s double s of x modulus of double less than modulus of s dash of x square is the to prove the equation that is modulus of dk by dx double greater than the k square of x x. So that is the finally you find out the lambda of x. Lambda of x is equal to 2 pi by kx. 2 pi by kx. 2 pi by kx. That value is a simplify d lambda by dx. D lambda by dx is equal to minus 2 pi k square of x dk of x by dx. And the similarly a small change of the value d lambda by dx double less than 2 pi. Double less than 2 pi. The small change of the wavelength over the some small interval of x and x delta x may be expressed as the delta y delta y delta y delta y is equal to delta lambda by is equal to d lambda by dx into delta x. The delta x is equal to, choose the value delta x is equal to lambda. Delta x is equal to lambda. That is the simplify the delta d lambda by dx. D lambda by dx is equal to d lambda by delta lambda by lambda and delta lambda by lambda double less than 2 pi. Double less than 2 pi. That is the fractional change in the wavelength. Fractional change in the wavelength per unit. Wavelength will be compared to 2 pi. Compared to 2 pi. The some condition may be is written as the momentum form. Momentum form. MH. Finally, MH modulus of dV by dx less than or equal to p square. That is the final equation, the WKB approximation method. So the classical approximation method only the sufficiently the rapid practicals. Large P, the moving in the field that does not vary too much from the value point to point, a small gradient. So this is the WKB approximation method. 10 marks question is a very very important question, this one. So next one, next one 253 page number. 253 page number. Page number. Time dependent partition theory. Time dependent time dependent perturbation theorem. This is also 10 marks or 5 marks question only. Anyone is take this important question, that one 5 marks question or 10 marks question, anyone that one. Okay, so this is time dependent participation theorem. The participation theory is presented is the Hamiltonian. We have to Schrodinger equation for the Hamiltonian function which are time independent. Hamiltonian function which are time independent. If the Hamiltonian presents only for the brief period of or varies regularly, the irregularly, which the time is impossible of the solve. The perturbation can be viewed into two different ways. If we split time in the infinite number of events, if we split time
Can't hear, sir. Sir, the video is stuck.
Hello, sir.
Please stay.
Hello, sir. Please continue your class.
హలో సార్ చెప్పండి.
So time dependent partition theorem. Clear? Video is clear.
Yes, sir.
Sorry for disturbing. So, time dependent perturbation theorem. Time dependent perturbation theorem is the similarly the wave function also undergoes to the changes that compare the original levels and are degenerate lifting the may be into the degenerate states. In the second point of the view, unperturbed state remain in the same, but the system will be undergoing to the transmission between the state. So that is depending on the time independent perturbation theorem. So this is perturbation theorem. Simplify the equation first. The Hamiltonian operator. Hamiltonian operation. As the equation Hamiltonian H is equal to H double dash plus lambda H dash. H is equal to H naught plus lambda H dash dash is the solve time dependent perturbation time dependent Schrodinger equation H cat bra n is equal to I H car dou by dou t kedra n in the case energy of the system is no more than the constant the time evolution of unperturbed wave function. In the case of the system is no more of the constant the time evolution of unperturbed wave function is kedra n is equal to e minus I e naught en and that is I e n by h cart చెప్పండి అదోగా నేను క్లాస్లో చెప్తున్నా తర్వాత లంచ్కి పోయి రాకండి ఎగ్జామ్ సరే so en of by etc n of r equal to 0 kedra. So we now introduce the additional parameter Cn of t which takes care of the perturbation effect into the wave function for the unperturbed system Cn star Cn star of t is equal to 1. Of t is equal to 1. Eta n is equal to summation n cn of t e power of minus I E n naught by h cot eta n naught. So substituting this equation 23.2 is the equation 23.3. This equation substitution equation 22.1. Sorry, 2. So substitute that equation. I h cot summation n dou by dou t cn of t e power of minus I e n naught by h cot eta n naught plus summation n cn of t minus I e n naught by h cot e power of minus I e n naught by h cot t eta n naught is equal to summation n e n naught plus lambda h dash to summation n cn of t into e power of minus I e n naught of t by h cot by n naught this. Take this. So where we have used where we have used h naught n naught is equal to e h naught is equal to e n naught n naught. So you are bracketing of the value. This is also you are bracketing. This is also bracketing. You have to multiply the s naught. So multiply in the Edra, which one? S naught. Let's multiply this. So I h cot summation n. This is a This equation multiply amma. Total is a multiply this equation finally. This equation the multiply the Kedbra is not value. Okay, that is the equation. So yeah, that is your observed equation. IH card summation n dou by dou t cn of t e power of minus e n naught of t by h card Kedra s by n naught is equal to summation n lambda s naught by n here is this is a h sum. This is also is a h term that one lambda s naught s by h dash summation n cn of t e power of minus I d n naught of t by h card Kedra n naught. So you are observe this IH card O CS as a you function the S terms. So that is dou CS by dou T e power of minus I e n naught by h card into t is equal to lambda into summation is common cn of t into Kedra s naught h dash n naught into t power of minus I v n naught by h card into t. This term this we common the this value, this value and h card h dash value and n naught value common. Summation any value is a common. Remainder value t power of this. So that is the value. So after IH card dou CS by dou T is equal to lambda summation n cn of t this value right is cn of t Kedra s naught h dash Kedra n naught into e power of minus I omega s n t Why are you here? Why you writing the I omega s n t? So this side is the n term. Here is this is the s term. This is the s. So is the s term and n term. You write the change in cross multiplication this. Convert into the cross multiplication this one. This case and this case both values you write this case is e power of minus I omega s n of t. That is a convert the equation. So I h cut dou cs by dou t is equal to lambda summation n cn of t h dash sn e power of hn e power of minus I omega sn of t. So here Sn value means this sum. This is S, this is the N value. Both values are functions. We converted Hamiltonian equation the function this sum. S value and N value. This is the S naught value here, N naught value. You write the Hamiltonian value. So S dash Sn into e power of remaining the value. That value you write this. So where dou cs by dou t is equal to lambda into summation n cn of t where h dash sn is equal to s dash h naught tetra h dash and n naught. That's the value. And omega sn is equal to es minus en by h cut. You write this both equations there. These two values you write that one individual part. So to solve the equation, one has to resort the perturbation techniques. Then let us assume that perturbation is weak and we expand cn of t and cn of t and cs of t and cs of t. The powers of perturbation parameters, the powers of perturbation parameters parameter is lambda. Okay, so that is converted to the cn of t and cs of t individual two cases. Cn of t and cs of t, two powers of particular the parameters. That is the two cases, dividing the two cases. Cn of t is equal to cn power of 0 lambda dash cn dash plus lambda square Cn square plus lambda cube Cn cube plus lambda 4 Cn power of 4 plus dash etc. Okay. At the same time, this is Cn of term values. This equation. The same time, second term, sorry, this equation number. That second one is this. So here Cs of t, Cs of t. That is also Cs naught plus Cs naught plus Cs naught plus Cs naught plus lambda dash Cs dash Cs dash plus lambda square Cs square plus lambda cube Cs cube plus lambda power of 4 Cs power of 4 plus dash this the equation. So is substituting the both equation Cn of t and Cs of t, two equation substitute in the equation 23.4. 23.4. So that is our observe. Equation you are observe 23.4. So substituting equation 23.4 both value equation. Both equation IH card dou by dou t into Cs power 0 lambda dash Cs1 Cs1 plus lambda square Cs square plus lambda cube Cs cube plus dash C power of 4 Cs power of 4 plus is equal to lambda s is equal to lambda summation Cn naught C lambda dash Cn dash plus lambda square Cn square plus lambda cube Cn cube plus lambda power of 4 Cn power 4 plus dash Sn dash e power of minus omega Snj So this is the collecting the terms and correspond to the different power of lambda, different powers of lambda, different powers of lambda, different powers of lambda, that is equal to, so that is 0th order. See the 0th order, that is equal to, we are substituting the 0th order, this terms and this. Okay, so that is the value I h start rho cs by rho t is equal to 0. This term, this 0 at the same time is equal to here rho cs or is equal to constant. Constant. So this is constant of is the initial state of the system. Initial state of the system, and they can be chosen properly in the case of the system properly if the state of the system is the completely known before is the application of the perturbation. We assume that the system is the particular state in the particular state at t is equal to 0. T is equal to particular state t is equal to 0. So that is 0th order. Let's second one, first order. The second one is the first order. First order. This is also collecting in the terms corresponding to the lambda dash. This is the corresponding to the lambda dash, corresponding to the lambda dash. Correspond to the lambda dash. So you are write this term here. First is 0 order is this one. First term is this one. Second term is this one. This is the similarly in the cases of the proof. That one. So first is order I h start rho cs1 by rho t is equal to summation n cn power of 0 e power of I omega sn of t h start sn. So this is the simplify the equation. You only cs1 is the term. Simplify the equation. This is the derivative part. This one is the derivative. This one the remaining the cs1 value. After that you change minus I h start. This one you have to do the derivative is also minus I by h start change. Start integral of minus infinity to infinity cn of 0 e power of I omega sn of t h dash sn dt. So the constant of integration is taken to be 0. In the order 0 is the order CS dash to 0. The CS of infinity minus infinity to this is equal to 0. This is similarly, since the CM since SM sorry CM this is the M not N no. CM naught is equal to 1. CM naught is equal to 1 and 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 CL this is the L, this is L is equal to 0 power of 0 ML that one. So you write the C I am not L I. So here I not equal to M function. I not equal to M. So that is also simplified here. CS dash is equal to minus I H cut CM not e power of I omega SM P H dash SM dt. So this states a simple form of the perturbation is the time independent expect. The time independent expect for the being turned on one term of and off on off one on the one time and off at the later time. So these two instead of 0 and t, instead of b 0 and t respectively CS1 is equal to minus I H cut H dash SM integral of log 0 1 e power of I omega Sn this is not Tm, this is J. We all multiply this. Okay. So this is J. So any T values you have converted to J. That one. Okay. So integral of J dt is equal to minus I H cut H dash SM This is integral. You convert the integral value this one. So e power of I omega Sn j by omega Sn. Sm not M N no M this is M. This also omega M Sm equal to 0 to 1. So minus that is the equation. Next to also minus H dash Sm by H cut into e power of I omega Sm of j by sir minus 1 by omega sm. Omega sm. So the probability of finding the system in the nth term, the probability of finding the system in nth term state at the time t is given by small s of c s square 4 small s of s m dash whole square by h square into it removes this formula simplification sin square omega s m t by by 2 omega sm square g equal to 4 minus of sm dash whole square sin square omega sm of t by 2 total multiply this is both values are multiply the remaining h square is the value h square and omega sm square you know? This above the is plotted as the function. The above is the order of the function. The above the function wf function omega sm. Order of the function omega of sm as the source of period. So that is the this. For example, the function in the wave. So here listen. The function is the wave here. So this is the wave function only. This is the wave function. This will be also same. Is the system. This is a system wave function. So here is a 0, 2 5 by t. Here this one, 2 5 by t, 4 5 by t, and 6 5 by t. This is a positive function. We also here minus 2 5 by t. This one minus 4 5 by t. Here this one minus 6 5 by t. This is the wave of the function. So this is the height of the main peak of the value is proportional to the t square value, and breadth is decreasing the proportional to the 1 by t. The area under the main peak of the increased value the proportional to the t. Okay, we see from the figure that the probability of transition is the maximum value. Constant of the maximum value omega Sn is equal to, this is the finally omega Sn is equal to 0. Omega Sn is equal to 0 and Es minus R this one Es minus Em is equal to 0. This is the both equations of the time dependent perturbation theorem. This is also very important question. Come on. Okay, and time is over. Okay, thank you. Anybody?
Okay. Thank you, sir.
Okay. I'll leave it then.